Okay, so now let's consider if we had a base. Okay, so let's say we had a barium hydroxide solution that had a concentration of 0.005 moles per liter. Okay, let's just say. So remember that you're dealing with a hydroxide. Okay, so first of all, you cannot solve for pH here. You'd have to solve for pOH first. Again, you have to consider how many hydroxides for every molecule or compound in this case. So because there's 2 hydroxides for every 1 barium hydroxide, this concentration to get the hydroxide concentration really would need to be multiplied by 2. So once you have that, you can then do your pOH by doing the negative log of hydroxide. Right? So then once we have that, we can then determine the pH. So negative log 0.01, so we get a pH of 2. And then to get the pH, right, you would do 14 minus 2, which would be 12 in this case. So how can this become a little bit more difficult? Is if you had to calculate this concentration first. So there are some on the worksheet that you're doing for this where you have to, you take, for example, the mass. They tell you the mass of barium hydroxide or whatever the compound is. You then have to figure out the moles. So then you do C is equal to N over V, and then you can solve for the next pH or pOH steps. Okay, so it can range from quite simple to obviously involving, 2 or 3 different steps here. So what about if we had the opposite? If we had the pH, but we wanted to solve for hydrogen ion concentration. So this is the opposite of a logarithmic scale. Okay, so what you would do is you put 10 to the exponent and the negative pH of whatever it happens to be. So for example, if I want the hydrogen ion concentration and they're telling me the pH is equal to 2, I would do 10 to the exponent 2.0, right? So 10 to the exponent negative 2 would give me 0.01 moles per liter. Okay, so whatever the pH is, you have this value. Now, if they give you the pOH, you would have to then solve for pH first, and then use that answer to determine the hydrogen ion concentration. Okay, so try these 2 out. Obviously, these are kind of very simple. We just want to get you in the hang of doing the calculations. When you go to do your worksheet, or you'll notice that they are a little bit more, they start off simple and then they go to more complex. So press pause, give these a try, and then we'll see how you do. Okay, so we have hydrogen ion concentration of this. So the pH is negative log of 4.7 times 10 to, that should be the exponent, negative 11, right? So negative log, remember to put your brackets, 4.7 10 to the negative 11. So you should get here a value of, so 10.33, but for 2 significant digits, we can put 10 with a decimal point. Okay, now here we have the opposite. Determine the hydrogen ion concentration if you have the pH of 10.33. So you're basically doing the opposite. So 10 to the exponent negative 10.33. This should give us a similar value. So 10 to the exponent negative 10.33. We get here 4.677 times 10 to the negative 11 moles per liter. And then we need 4 significant digits, actually, so it already is 4. There we go. All right, there you go, pH. So these calculations can become even more complex than this here. This is just your grade 11 introduction. Okay, in grade 12, you'll learn a little bit more about pH. So this is your opportunity to practice and see how you do.